Welcome to Brain Vision.
To prove this equation of dr dt, we're going to start with the fact that the force from the Coulomb force is equal to negative k times e squared divided by r squared, which is equal to the mass times the acceleration. And the energy, E, is equal to ke squared over 2r. So first thing we're going to do is use this force equation to solve for acceleration. So we find that acceleration is equal to negative k e squared over r squared. And in the equation we were given for dE dt, we have an a squared term. So let's go ahead and get an a squared term here. So a squared is equal to negative k squared e to the fourth r to the fourth. Oh, I forgot my m on the bottom. There should be an m down here. So since we were solving for a, and this is divided by m squared r to the fourth. Now for E, we can take dE dt. So we're going to find a version of dE dt here and set it equal to the other dE dt, since this one has an r in it, and that will allow us to find our dr dt. So dE dt is equal to ke squared over 2, since all of those are just constants, multiplied by negative 1 over, this should be negative ke squared, negative, times 1 over r squared. So this is taking the derivative with respect to r, derivative of t with respect to r here, times dr dt. So we had to use the product rule. Okay. So we also have another equation for dE dt, the 1 over 6 pi epsilon naught e squared a squared over c to the third that we were given. So if we set this equation of dE dt equal to that, we can solve for dr dt. So doing this, we have 1 over 6 pi epsilon naught multiplied by e squared a squared over c to the third is equal to 1 over 8 pi epsilon naught The reason it's equal to 1 over 8 pi epsilon naught here is because k is equal to 1 over 4 pi epsilon naught. And so we replace k with 1 over 4 pi epsilon naught, and then you also have this 2 down here. So that gives you 1 over 8 pi epsilon naught. It's multiplied by e squared over r squared. So the negative signs canceled out. dr dt. So now solving for dr dt, we have dr dt is equal to the pi and the epsilon naught are going to cancel. So we're left with negative 8 over 6 r squared a squared over c to the third. And now that equation that we found for a squared is going to come in handy. So we're going to plug that in here where we found that a was equal to negative k squared e to the fourth over m squared r to the fourth. And remember, k is 1 over 4 pi epsilon naught. So this gives us negative e squared divided by, we have 12 pi squared epsilon naught squared r squared m squared times c to the third. And this is actually the equation that we were asked to show, so we just proved it. We can box all of this in as our solution to the question. For part B, we are asked to find the time interval over which the electron reaches the r equals 0 state, starting from r naught equals 2 times 10 to the minus 10 meters. So to do this, we're going to take the integral of dr dt. So what we have here is dt is equal to 12 times pi squared times epsilon naught squared times r squared times m squared times c to the third all over negative e squared. Okay, and then this is dr. Well, everything except for r is a constant. So I'm going to plug in those constant values. M is the mass of the electron. C is the speed of light. Epsilon naught is just that constant. Pi squared, of course, is just a constant. E is the charge of the electron. So plugging in all these values, we'll take the integral of both sides here. We find that t is equal to, and this integral goes from r naught to r, where those values are given, of negative 3.172 times 10 to the 20. So all those constant values came out to equal 3.172 times 10 to the 20. Multiplied by r squared. Sorry about that. That's my mailing address. Let me turn that off. So this is multiplied by r squared dr. Okay, so we integrate over r squared dr since the other value is just a constant. And we find that t is equal to negative 3.172 times 10 to the 20 and then the integral of r squared gives us r to the third over 3. And then this integral is going from r naught to r. So we plug in our values of r naught and r here. So we take r to the third over 3 when it's equal to 0 minus r to the third over 3 when r is equal to 2 times 10 to the minus 10. And this gets rid of that negative sign that we have there. And this gives us a value of 8.46 times 10 to the minus 10 seconds. We can box that in as our solution for part B.